Hello, and welcome to problem set 117 in our calculus classroom. Today we're going to talk about geometric and telescoping series. Should be a blast because you're going to have some friendly equations that basically solve it for you. So, for a geometric series, you should remember this geometric. From pre-calculus, each time you have a number multiplied by some common ratio. So if my first term is 1 and my common ratio is 2, maybe 1 plus 2 plus 4 plus 8 plus 16, and so on. Now, that geometric series with my common ratio of 2 will diverge because the numbers keep getting bigger and bigger. We're adding bigger numbers and bigger numbers. It's never going to converge. But if we have a series that has a geometric series where we're multiplying by a number less than 1, or an absolute value less than 1. If r, which in this case is 1/2, is less than 1 in absolute value, then we know this converges. Why? Well, we're adding just smaller and smaller bits, and that's how geometric series work. So what's the formula for that? Well, the formula for the sum of a geometric series where you have a first value, so let's call this G naught, and you have a common ratio that you multiply by every time. Then the formula is as follows. It is A, or the first term, let's call it A instead, over 1 minus R. So if I wanted to figure out what this geometric series converges to, I would plug in A, which is the first term, 1, over 1 minus the common ratio, which is 1/2. 1 minus 1/2 is 1/2. So this converges to 2. Are we surprised? We started with 1, then we added 1/2, 1/4, and 1/8. I can even draw a picture to figure that one out. But that is how a geometric series works. So let's find the sum of this geometric series. All right, it might help to write out a few terms just to get a good idea of what's going on here. So we have 2 over 3 plus 2 over 9 plus 2 over 27 plus 2 over 81 plus da, da, da. So what's my first term? Well, that looks like 2/3. What's my common ratio? Well, each time I'm multiplying by 1/3 to get the next one. R in its absolute value is less than 1. So we know that this geometric series is going to converge. So I can use this formula right here. This is gold. Write it down. The sum of a geometric series is A over 1 minus R. So I have 2/3 over 2/3, which is 1. So this geometric series will converge to 1. All right, so that's the first part. The second part of our lesson is pretty cool. By the way, I love when we talk about convergence because we are settling upon a number. We're settling upon something that after we add millions and billions and an infinite number of terms, we're settling nicely on something. And it reminds me constantly of how our lives are not this like just one event and then that's it. You know, we give our lives to Christ and that's amazing, but then there's the rest of our life to live out. And so every little decision, every little choice, every little thing in there either draws us closer to Christ or moves us away from it. And so I hope that you guys are making choices that move you closer to Christ every single day. Now, let's talk about some of these problems. A basketball is dropped from a height of 10 feet. Each time the ball hits the floor, it rebounds to a height of 9/10 its previous fall. What is the total distance the ball travels? Now, this is cool because you have to consider both the falling part and the rebound. So, you have to do a little bit more thinking here than just plugging it into this equation. So it falls 10 feet and then it rebounds 9/10 of its previous fall. Okay, so that common ratio would be 9/10 and our initial would be 10. So we can find out how far it falls using this equation. But that doesn't give us the full picture. Why? Because that only counts the falling part. If they ask for the total distance it travels, we must also include the rebound. So you might think, oh, well, it's just 200, because every time it falls, it goes back up. That's true, except the first time. So I'm only going to add 90, because I'm going to leave off this first 10, and I get 190 feet. It's a funky problem, but I know that you guys can get that. Now, moving on, we're going to talk about telescoping series. Now, the reason it's called a telescope is you have to imagine those old school monocular telescopes where you pull them out and then they fit back together again. The idea with this series, and we'll look at one today, is that certain terms of it fit together with other terms. So we have 1 over n plus 1. Okay? Now, how am I going to make this fit together with other terms? Well, again, the way we're going to start these out is a lot of times if we don't know what we're doing, there we go, sorry, trying to get that stick, is we'll just write out a few terms and see what happens. So let's look at the n equals 1 term. We have 1 over 1 times 2, that's 1/2, plus 1 over 2 times 3, which is 1/6, plus 1 over 3 times 4, which is 1/12. So that doesn't look very helpful, right? We're grasping at straws here. So let's see if there's anything else we can do with this. It's not a geometric series because I'm not multiplying by a number, a common ratio, every time. So I have to look for other tricks. I don't see it right now. The other trick that I do see is that I can split this into 2 fractions. And so what I want to do is I want to do, just like we did with partial fractions, break this up into a fraction of n and a fraction of n plus 1. It turns out if you do the whole work with the partial fractions, you find out that a is positive 1 and this is negative. So now in this form, so again, you're going to have to do partial fractions to find that. We already learned that. Now, if I write out the first couple of terms, the first sum is 1 minus 1/2. My second sum is this, 1 minus 1/2, plus when n equals 2. That would be 1/2 minus 1/3. Okay, now I'm seeing this telescoping a little bit more. Notice how this 1/2 and 1/2 cancel each other out. Let's write out the third term. Those cancel, so I have minus 1/3. My third term, n equals 3, I will add 1/3 and subtract 1/4. Notice that these terms cancel out. So each time, the following term cancels out the previous one. And so what does this converge to? Well, it converges to 1. Equals 1. Why? Because each time the subsequent term is going to cancel out the previous one, and these are getting smaller and smaller and smaller, so eventually we get 1. And that, my friends, is lesson 117.